So if we discuss about sound, so first we need to discuss the nature of the sound, that what will be the nature of the sound, because sound is also like a wave, a type of wave which carries energy from one point to another, right? So
Yes.
sound also transfers energy from one point to another. And if we categorize the quantity or the concept of sound in the types of wave, so sound is normally known as longitudinal wave, right?
Yes.
Sound is longitudinal in nature. Sound is longitudinal wave. It means that the motion of the particles will be in the same direction of the wave travel, right?
Yes.
So longitudinal means basically the motion, or you can say that the vibrations. Vibrations will be parallel to the wave travel, or the direction of wave travel, right?
Yes.
And if we further discuss about, so the nature of the sound is longitudinal, and what will be the next concept regarding it? Sound needs some medium to travel, right?
Yes.
To discuss about the other properties of sound. So sound requires some medium to travel, or generally in our daily life, we can say that the sound requires some air medium to travel from one point to another. Okay,
Yes.
medium to travel. About the speed of sound. So what will be the speed of sound? Do you remember the
Um.
exact value of the speed of sound?
No.
Okay. Any guess or any rough idea?
No. Wait.
Will be in the values of hundreds or thousands?
I think 1,000.
No, it is in the values of 100. So the speed of sound will be in between speed of sound. We mention speed with the symbol of V. The speed of sound normally ranges from 330 to 350 meter per second, right?
Yes.
There is a different range of sound, not exact value of sound, because you know that in air molecules or in our atmosphere, there are some other factors like temperature, pressure in the air molecules, or you can say in our atmosphere. So due to some changes in the pressure and the temperature, there may be some variation in the speed of sound, right? So sound will not always travel with the equal speed or the same speed every time. So there may be some variation due to the change in temperature and change in pressure in our atmosphere. So that's why there is a range of sound we normally write, which is equal to 330 to 350 meter per second, right?
Yes.
So this is the speed of sound. And if you want to calculate the speed of sound in some other case, or if the numerical values are given there, so how can you calculate the speed of sound?
Speed of sound?
Yes. Because
Like,
all
can you,
this is also
what?
sound is also a form of wave or type of a wave, right? It is a longitudinal.
Yeah.
And in previous chapter, we discussed about the formula to calculate the speed of wave. So what was that formula to calculate the speed of wave?
V is equal to F by lambda?
Yes. So we use same formula in this concept if they want to give you to calculate the value of sound somewhere. So you can use that same formula V equals to F lambda. Okay, because in longitudinal wave there is also maybe different frequency and the wavelength, right? You
Yes.
can use that formula again to calculate the speed of sound. And if we discuss about some other points or some other phenomena that normally happens in sound. So let's suppose if you are alone in a room, there will be a empty room and you are alone in that room. And when you try to speak or want to say some word in that empty room, so what will be your observation in that room? बिल्कुल
It will
खाली.
echo.
Yes, because sound waves, there is no obstacle in between the reflecting surface and the source of sound. So sound waves will reflect back after striking from the
The wall.
wall or any obstacle which is placed in between the
Yes.
surface or the source of sound. So there is a phenomena of echo there. And if you want to explain or if we want to write some values for that, so echo means reflection of sound wave. Reflection of sound waves.
Sir, I have a question.
Yes.
So sound echoes when there's no obstacle,
Yes.
right?
Normally it happens when there is no obstacle, but let's suppose there is some whiteboard or some type of a sheet placed before the reflecting surface. So sound will also
Yeah.
reflect from that surface, right? Not from every object placed in that room. So there may be some
Mm.
or some type of plane surface. So sound will easily reflect back from that surface.
So, sir, like, what about gatherings and all? Like, if there's people, if they speak in mics, the voice echoes sometimes.
Yes, because there will be a different type of sound producing there because that sound was artificial, artificial in the sense that that voice is not a normal sound that is known as electromagnetic waves, or you can say that radio waves, right? Because
Yes.
in that concept or in that situation, your energy is going to be converted from mechanical energy when you are talking or when you are speaking in some gathering or in a crowded with the help of mic or any transmitter. So your energy is going to be converted from mechanical to the electromagnetic or radio waves, right?
Yes.
So that's why that is the different type of sound wave or the transformed form of the sound wave. So that's why there may be echo, which can be produced with the help of like this sound system which is connected to the mic, right? So that was
Yes.
okay. And if you want to produce a pure echo with the help of sound wave, so there may be some conditions for it, right?
Yes.
That was also the phenomena of echo, but those waves are radio waves, or you can say that these are artificial or electromagnetic waves. So that
Yes.
are some different from the original sound waves, right?
Yeah.
So there may be a change of form of waves, or you can say that their energy is transforming from one to another. So that's why we can produce echo in that condition or in that example with the help of sound system, right?
Yes.
Okay. And if there are so many people in the room, so why sound will not reflect in that situation?
Because the people are obstacles
Okay.
for the sound.
Why? So what will happen if there are so people?
The sound won't echo.
Why? वहां भी तो एको हो सकता है, वो पीपल से स्ट्राइक करके रिफ्लेक्ट हो जाए.
But the people aren't a plain surface.
Okay. Any other reason?
Um,
Because normally sound can only reflect from a solid material, right?
yes,
Because if there is a solid material, and if we discuss about the speed of sound in different materials, let's suppose we discuss about the speed of sound in different material. There is a solid material, right? Then the liquid one, and the last one is of gas. So if you want to compare the speed of sound in these type of material, which material sound is going to be travel fast?
solid.
Solid. So let's say that in solid material, sound travel faster than liquid and gas. And if we
Yes,
about liquid, greater than gas and less than solid, right?
yes,
And in gas, the sound speed of sound is lower as compared to the liquid and solid, right?
yeah,
So speed of sound is greater in solid, and you can say that moderate or medium, or you can say that it is greater than speed of sound in gas. And in gases, the speed of sound is the lowest one as compared to these materials, right?
yes.
And why this actually happens? Why sound travel fast in solid?
Because the particles in solid are packed closely together, and when sound hits solid, it vibrates.
Yes. So in solid, you already know about that the formation of solids are the molecules are tightly packed with each other, so can transfer energy rapid, right? Because their formation is very strong, both liquid and gas. Particles are tightly packed with each other. Particles are tightly packed, so that's why they transfer energy rapidly as compared to liquid and gas, right?
Yes,
So this is the main reason why speed of sound is greater in solid as compared to the other fluids, that will be liquid and gas. And we are discussing about that if there is a crowded audience there, or there is a room in which many people are sitting and talking to each other, and there is no reflecting surface and there will be no echo going to be produced with the sound wave. So that actually not happens because the soft material, there are some soft materials, right? Because not every object placed in our room is a solid one, right? Because there are some chairs or there are some bags and type of clothes there. So
yes,
that materials absorbs the energy, right?
yeah,
So that's why the maximum, or you can say that the major amount of energy going to be absorbed by soft material. So that's why in crowded place or in crowded room, there will be no effect of echo there, right?
yeah,
So you can say that in crowded place, sound energy or sound waves, energy of sound waves going to be absorbed by soft material, right? absorbed by soft material. So that's why there will be no effect of echo there, right?
Yeah.
So this is the main reason. And if you want to calculate the distance or the speed of sound with the help of the phenomena of echo, so how can you calculate the speed or distance with the help of the phenomena of echo? Any idea?
Um.
Okay, let's consider example, then formula for it. Let's suppose a solid wall there from which sound molecules, or you can say the air molecules which are vibrating with the help of sound going to be strike there. So there is
Yes.
wall over here. So this is our wall, and let's suppose there are sound waves which are going to be travel from left to right. Okay. So
Yeah.
we suppose only two types, or you can say there are two waves which are traveling from left to right. Then after reflection, this is the origin or the starting point of sound waves, right? This is the starting point. This is also the starting point for the sound waves, which is going to be traveled from one point to the wall. And after reflection, sound wave will bounce back, right?
Yeah.
Let's suppose, yes, this after reflection, sound wave is going to be travel in the backward direction, right?
Yes.
So sound waves are going to be reflect back or bounce back. Okay. And if you want to calculate the speed of sound in the phenomena of echo, the speed of sound. So what will be the basic formula of calculating the speed? That is V equals to distance over time, right?
Yeah.
We learned that formula in the chapter of motion, that speed is equal to distance over time, right? So we use that same basic formula for this situation. But if you want to calculate the distance, so what will be the distance? What will be the value of distance in this situation?
Like the formula of distance.
Or you can say that what will be the estimated value, or what will be the journal term for the value of distance? Let's suppose if this distance will be equal to 3 meters, right?
Yeah.
So if we want to mention the distance in this formula, so how we are going to place the value of d in this equation or in this formula?
3 upon and then the time.
3 upon time. But you
Yeah.
the situation that waves are reflecting. First, they go in the forward direction, then they are bouncing back, right?
Yeah.
So 3 meters in the forward direction plus 3 meters in the
Backwards.
backward direction. So distance is going to be doubled, right?
Yeah. 6.
So formula is going to be like this, that 2 times distance divided by the total time, right?
Yeah.
Let's suppose the time taken by waves, or you can say the total time for the wave is equals to 5 seconds. 5 second is very greater section. Let's say that 0.2 second, right? Sound
Yes.
to be travel from one point to another or then bounce back. It takes total 0.2 seconds. So we can say that 2 multiplied by 3 divided by 0.2. Okay. So
Yes.
the value of sound in this situation, what will be the value of sound?
Um, 30.
30, exact 30.
Yeah.
Okay, so 30 meter per second, right?
Yes.
So 30 meter per second will be the speed of sound waves in this situation. So now you got the basic concept. How can we calculate the speed of the phenomena of echo, right?
Yeah.
Or you can simply write that the total distance covered by the sound wave divided by the time, right?
Yes.
Also use this formula in the example or in the explanation of giant ships which are moving in a deep water. When waves are going to be generated from the engine or the siren or something, sound are produced from the ship, going to reflect from the deep of the water, right? Rock there, because there is a radar system we use in our ships, or you can observe that one in the movies or some video clips, right? There
Yeah.
are system like grid type graph screen in the computer system, and there are some continuously pulse or a point indicating. So that can also be observed with the help of sound wave. When let's suppose if there is a ship, and if you want to observe the actual distance of a ship from some solid object under the deep sea, right? Let's suppose there is a ship. Let's consider the example of the giant one, which is known as Titanic, right? So there is a Titanic ship which is going to be travel in the sea, and this is the level of sea there, right?
Yeah.
And there is an hidden object which is under the deep water somewhere at this point, right? So there is a
Yes.
object inside the water, and if you want to calculate the distance between the ship and the rock, so how can we calculate the distance? Let's suppose, so we are discussing about if we want to calculate the distance between the ship and the rock or the solid object which is under the deep water. So we can use that phenomena of reflection of sound. Let's suppose there are some waves or sound waves is going to be generating from the ship, right? Because there is a turbine, there is a propeller, there is a heavy engine working in uh, the engine system or the main system of the ship, right? So when
Yeah.
are going to be reflected from that solid object, okay? So we can calculate the time in which waves are going to be reflected back from that solid object, right? It takes some,
Yes.
so we measure the total time of the reflection from that surface. Let's suppose there is a time of 0.8 seconds, right?
Yeah.
And the speed of ship is around 1000 meter per second. Okay. So if you got these two values, so you can easily identify the actual distance between your ship and the solid object
Uh.
under the deep,
Yeah.
right? So this formula or this phenomena also helps you in the deep water or calculating the distance between the heavy objects in the deep water, right? There is
Yes.
a question in your past paper regarding this example. So we can easily calculate with the help of this formula v equals to distance over time, and distance is equals to velocity time multiplied times equals to the total time, right?
Yeah.
So this will also helps you to find out the distance. Any confusion?
No.
Okay. So now let's move towards another concept which is related to sound. We discussed about the reflection and we discussed about the speed of sound in different medium, that is solid, liquid, and gas. There are some different types, or you can say that variation of speed of sound in liquid, solid, gases, right? And there
Yeah.
are also many varieties or many type of material in solid like aluminium, brass, copper. So there may be some variation in speed because the formation of the materials are different, right? And
Yeah.
we discuss about the factors affecting sound waves. ठीक है, हमने अगर ये देखना हो कि हमारे पास साउंड किन फैक्टर से इफेक्ट होता है, ठीक है, तो वो फैक्टर्स कौन कौन से होंगे हमारे पास. Let's discuss about the factor affecting sound waves. Factor affecting sound waves. So what will be the first factor?
Um.
Any idea? First factor is of loudness, right?
Yeah.
So if we discuss about our first factor, which is of loudness, so loudness we actually distinguish between the loud and the faint sound, right? So if we
Yes.
discuss about the first phenomena or the first factor affecting sound, so the first one is loudness. This is the phenomena of or the factor of loudness. So we can say that loudness is basically the property of sound which help us to distinguish between helps us to it is a factor which helps us to distinguish between loud and a faint sound, right?
Yeah.
Okay, there is some distinguish between or differentiate between two types of sound waves, between faint and a loud sound, right?
Yeah.
And on what factor this loudness depends? That how can we identify that sound is loud and sound is faint? If
Um.
you answer the question with the help of the properties of wave we already discussed in previous chapter.
Yeah.
So how can we measure the loudness of a sound? Which factor is important to calculate the loudness?
Wavelength.
Wavelength,
No. Frequency.
frequency. Okay. So the factor which is very important to identify the loudness of sound is loudness depends upon,
Speed.
no, only one factor is remaining.
Oh no. It depends on the medium.
No, it depends upon an amplitude. Okay.
Yeah.
So loudness depends upon amplitude, maximum displacement, or the maximum height of wave from the mean position, right?
Yeah.
Loudness depends upon amplitude, or amplitude means greater the amplitude, louder will be the sound, right?
Yeah.
So we can write that greater amplitude will gives you a loud sound, and the smaller amplitude will gives you a faint sound. Greater amplitude gives you louder sound, right?
Yeah.
And there are some other factors on which loudness also depends. Uh, Loudness also depends upon the area of vibrating body, right?
Yeah.
So loudness also depends. It also depends upon the area of vibrating body. An example,
Uh, an empty room. Like,
okay, empty room, there is this greater space to vibrate molecules, right? And if we take
yeah.
example of two different drums, right? One is the smaller one and other one is greater than the first one, right? So
Yeah.
here is a drum which is very small in size, and there is an other drum which is greater, or you can say that double in size as compared to the first one, right?
Yes.
So you can easily compare that there is a greater area in drum number 2 as compared to the first one, right?
Yes.
So which drum will produce loud sound? First one
The
or the second
second.
one? The second one. Because there is a greater space for molecules to vibrate. So the greater the amplitude, the greater will be the loudness.
Yes.
Greater area as compared to the first one, it also means the greater amplitude. And when amplitude is greater, it means that there will be a loud sound, right?
Yes.
And there is also another factor, the last factor. Let's suppose if you are standing far away from your friend and you want to talk with your friends, you need to be shout और in आपको shout करके उससे बात करना पड़ेगी, तो उसको आपका sound जो है वो सुनाई देगा, right?
Yes.
क्योंकि आपका distance increase हो गया. It also depends between the source of sound and the observer or the listener.
Yes.
So it also depends upon the distance between a source and the observer. So it also depends upon the it also depends upon the distance between the source and observer, right?
Yes.
Because if someone is sitting near to the loudspeaker, तो उसको तो इतना क्लियर साउंड सुनाई देगा कि अगले 2-3 घंटे तक जो है वो उसके कानों से वो आवाज नहीं जाएगी, क्योंकि उसका डिस्टेंस इतना शॉर्ट था कि उसके एयर ड्रम्स जो है वो काफी टाइम तक वाइब्रेट ही करते रहेंगे, right?
Yes.
So this is the factor, distance between the source and the observer, and someone is sitting away from the loudspeaker. So there is a faint sound which is going to be observed by that observer, right?
Yes.
Any confusion?
No.
Okay, so this is the first factor. And if we discuss about if we want to compare the sound of your voice and my voice, so किसकी आवाज जो है वो सबसे ज्यादा खूबसूरत है, आपकी या मेरी?
पता नहीं.
सबको अपनी आवाज ही अच्छी लगती है, राइट? हाँ,
Yes.
लेकिन अब जो नॉर्मली हमारी वॉइस में डिफरेंस होता है, देयर इज अ डिफरेंस ऑफ क्वालिटी, और यू कैन से दैट द formation of sound, or like quality of sound is different. If we compare the sound of a baby, sound of an old man, sound of a woman, sound of a male, और different ages के हम different sounds को compare करें, तो सबका sound different है एक दूसरे से, right?
Yes.
और सिंगर्स का साउंड सबसे अच्छा होता है, ठीक है, क्योंकि उनके पास साउंड की क्वालिटीज को वेरिएट करने की बहुत अच्छी उनमें स्ट्रेंथ होती है, ठीक है। तो
Yes.
एक और फैक्टर है, देयर इज अनदर फैक्टर ऑफ साउंड ऑन विच साउंड डिपेंड्स। तो सेकंड फैक्टर ऑन विच साउंड डिपेंड्स इज ऑफ पिच, राइट?
Yes.
तो सेकंड वन इज ऑफ पिच। And what is the main purpose of this factor? It helps us to distinguish between
Loud and faint.
no, we already discussed about it. अगर हम दोनों सेम ट्यून में बात कर रहे हैं, ठीक है, हम इतना लाउड भी नहीं बोल रहे, इतना फेंट भी नहीं बोल रहे, लेकिन फिर भी हमारे साउंड वेव में डिफरेंस है, हमारी साउंड जनरेशन में डिफरेंस है। तो इसमें एक डिफरेंस ये आता है कि जो नॉर्मली फीमेल्स और वुमेन्स की वॉइस होती है वो थोड़ा सा शार्प होती है, राइट?
Yes.
उनकी आवाज चुभती है, ठीक है। हाँ, और नॉर्मली जो मेल्स और वुमेन्स और बॉयज की वॉइस होती है वो थोड़ी सी हैवी होती है, राइट?
Yeah.
तो पिच बेसिकली हेल्प अस टू डिस्टिंग्विश बिटवीन अ श्रिल एंड अ ग्रेव साउंड, राइट?
Yeah.
Shrill and a grave sound. And how can we measure the pitch of a sound? And how can we identify the sound is going to be shrill or the sound is going to be grave? Pitch basically depends upon the frequency, right?
Yes.
Pitch depends upon the frequency. Pitch depends upon the frequency. So in shrill sound, there is a high frequency, right?
Yes.
Which means that your sound has or your voice has high frequency because your voice is more shrill than my voice, because my voice is grave but beautiful. Low frequency in grave sound, right?
Yes.
Okay, so there is a difference between this shrill and a grave sound. And if you want to distinguish between shrill and a grave sound, you can use the factor of frequency. If there are greater number of waves in 1 second or in a unit time, so sound is going to be shrill, okay? And if there is less number of waves generating in a unit time, so there will be a grave sound, right?
Yes.
So this is an other factor on which sound depends, right?
Yeah.
Any confusion?
No.
So there is an other factor of sound which is known as quality of sound, right?
Yes.
And if we discuss about the quality, let's suppose we हम मार्केट से परचेज करके लाते हैं दो हेडफोन्स, और उन दोनों में से वन हेडफोन हैज ग्रेटर क्वालिटी एंड द अदर वन इज लो इन क्वालिटी, So we compare, or we are using the term quality there. We don't use the actual meaning of words in our daily life, but in sound there is a term, or there is a factor which is known as quality. And quality basically means if we are producing same sound of same loudness and same frequency, right?
Yes.
So basically it helps us to distinguish between, or we can identify the difference between. You can simply write, it helps us to identify the difference between two sounds of same loudness, right?
Yes.
And frequency also. If there are two sound sources and we are observing the sound from those two sources, and there is a difference in the sound of those two sources, so how can we identify the difference? With the help of a factor which is known as quality, right? So which factor is going to be different there?
Yes.
Let's suppose if there are two materials or two source of sound. The first one is a piano. If there is some background music in some video, and if you identify the musical instrument in that video, so you know about the real sound of these two musical instruments. So if these two materials are going to be played at the same time, so you can identify the difference between piano and violin. Why?
Because they have a different pitch.
Different pitch. Okay. Let's suppose if the pitch of both piano and violin is same, because I already written that these sounds are of same frequency. Same frequency means the pitch is also same. Same loudness, same
Yes.
pitch. So both above factors are same in this situation. So now how can you identify the difference?
Uh,
So there is a
the
difference on
quality.
the quality, right? And on which factor quality depends? It depends upon the waveform, or in simple words, you can say that the shape of the wave, right?
Yeah.
Let's suppose there is a waveform or the shape of a wave of piano like this, some distorted line there, right?
Yeah.
And if we draw the waveform for the piano, let's draw the waveform for the piano one.
Violin.
Oh, sorry, violin. So you can clearly observe that the waveform of piano is completely in a wavy form, right? In the shaky form.
Yes.
And in violin, this is not the actual waveforms of the violin and piano. I give you the example that how can we differentiate the quality of two same loudness and frequency sound, right? So
Yes.
the difference between them is of waveform, or the orientation of wave, right?
Yes.
So there is different waveform of these two materials. So that helps you to identify the difference between these two types of same loudness and frequency sound, right?
Yes.
So basically there is a difference in the waveform of the sound wave. Okay.
Yes.